Okay, so this is problem number 5. An 8 kilogram rod of length L, so this is your rod of length L, is attached to collar. So these are your collar at point A and dot at point B, which may slide freely along the guides shown. Knowing that the rod is in equilibrium and that beta is equal to 30 degrees. Okay, so your beta in here is equal to 30 degrees. Determine A, the angle theta that the rod forms with the vertical. And letter B, the reactions at A and B. So first, let us try to draw the free body diagram of rod AB. This is your rod AB. Okay, so this is now your point A. This is now your point B. So your rod AB is making an angle theta with the vertical. So this is your theta. Okay, so we have the length of the bar is equal to L. So we now have the forces acting on the rod. So we have the weight, which is equal to W. This is the weight, and this one is now equal to W. So this is L over 2, and that one is L all over 2. So we have the reaction at point A. You try to take note that if you try to go back to the common types of supports and reactions, so this is a member pin connected to collar on smooth rod. And therefore, the reaction is perpendicular to the smooth rod. So we have the reaction at point A. So this is perpendicular to the smooth rod. So I'm going to consider, this is now your RA. And then we also have that is perpendicular to the smooth rod. So this is, okay, so you try to take note that this one in here is now your smooth rod. So if this is the smooth rod. Okay, this is the action of the smooth rod. And then we now have, it is perpendicular. And therefore, this is now the reaction at point B. So I'm going to consider this is now your R sub B. So this rod in here is making an angle of 30 degrees with the horizontal. Hence, it will now going to make an angle of 30 degrees with the vertical. Okay, so this one in here, so this is equal to 30 degrees. Okay, so this is now your smooth. So this is the smooth rod. And this one in here is 30 degrees. Okay. Now, so first, let us try to determine your weight W. So, the mass of the slender rod is equal to 8 kilograms. Hence, your W is now equal to the mass, which is 8 kilograms. Multiply this by 9.81 meter per second square, or this is therefore equal to 78.48 kilogram meter per second square, or that is equal to newtons. So let's try to determine the distances in here. So if I'm going to get this distance in here, and this is equal to, I'll consider this one as x, and this one in here, which is equal to y. So that is equal to y. So if you try to get, if that is an angle theta, then this is also equal to theta. So that if you try to get cosine of theta, this is equal to y over L. Is y all over L. Hence, the value of y is now equal to L cosine of theta. Next, sine of theta, this is your theta. Sine of theta is equal to x, so is the opposite side, all over L. So the value of x is equal to L sine of theta. So we now have the value of L. So I will going to consider that this one in here is x of 1. So this is x1. So this is now your x1. Using ratio and proportion, x1 is to L over 2. So this is now your L over 2. This is your L all over 2. So x1 is to L over 2. This is equal to x is to L. It's now your x is to L. That is x is to L. And therefore, you have your 2x1 is to L is equal to x, which is L sine of theta all over L. So, cancel out. Your x of 1 is equal to L sine of theta all over 2. Or x1 is equal to 0.5 L. Multiply this one by sine of theta. Now, let us try to determine the horizontal and vertical component of the reaction at point B. So we now have your RB horizontal is equal to RB sine of 30 degrees. So that is RB sine of 30 degrees. And your RB vertical is equal to RB cosine of 30 degrees. Knowing now your RB and RB horizontal and RB vertical, so from this diagram in here, so this is your x, this is your y, and this is your x of 1. So that if you're going to take summation of forces, vertical is equal to 0, upward forces positive. So we now have your RB vertical. So, this is your RB horizontal, and that is your RB vertical. So your RB vertical is going up, RB vertical minus W is equal to 0. So your RB vertical is now equal to, transpose that to the other side of the equation, that is 78.48 newtons. And then, summation of forces horizontal is equal to 0. We now have to the right forces positive. So we have minus RA. And then plus RB horizontal plus RB horizontal plus RB horizontal is equal to 0. So your RA is now equal to, your RB horizontal is RB sine of 30 degrees. So your RA is now equal to, so your RA is now, so we have RB horizontal. So your RB horizontal, so RB horizontal is equal to RB sine of 30 degrees. So that is RB sine of 30 is now equal to RB, okay, sine of 30 degrees. So how are we going to determine, therefore, the value of R? So let's try to determine now the value of RB. So your RB vertical, so from this equation, RB vertical is 78.48, and that is therefore equal to R sub B cosine of 30 degrees. So that the value of R sub B is now equal to 90.621 Newton. So let's try to substitute RB in this equation. So that your RA is now equal to, RB is 90.621 Newton sine of 30 degrees. Hence, the value of RA is now equal to 45. So we have 45.31 newtons. So that is therefore the value of RA. Okay, so let's try to get moment about point B. So summation of moment about B is equal to 0. So I'm going to consider counterclockwise moment as positive. So we have your W multiply this one by, okay, so the moment arm of W about point D is 0.5 L sine of theta. That is 0.5 L sine of theta. And then your R is going clockwise. So we have minus RA. The moment arm is L cosine of theta. L cosine of theta. This is equal to 0. So the value of W is 7. The value of W is 78.48 newtons. So we have 0.5 L sine of theta. So we have minus RA L cosine of theta is equal to 0. So your L will cancel out if you transpose this to the other side of the equation. So this is 78.48 by is 45.31. We now have sine of theta. And this is therefore equal to RA cosine of theta. And RA is, so we now have 78.48. 78.48 is W. So the value of W in here is 78.48. So the moment arm is 0.5 L sine of theta. And then your RA is, the value of RA is equal to 45 point, okay, so this is equal to 78.48 times 0.5, so that is equal to 39.24, so that is sine of theta, and this is equal to RA, and your RA is 45.31 cosine of theta. Okay, so your L and L in there cancels out if you transpose this to the other side of the equation. So we now have sine of theta over cosine of theta is equal to 45.31 all over 39.24. Sine over cosine is tangent of theta is equal to 45.31 over 39.24. So that your theta is now equal to the arc tangent of 45.31 all over 39.24. So the value of theta is now equal to 49.11 degrees. So we have problem number 6. The wall footing, so ito yung wall footing natin, is used to support the load of 1,000 to 12,000 pounds. Determine the intensities W1 and W2 of the distributed loading acting on the base of the footing for equilibrium. So first, let us try to divide this distributed loading. So we have a uniformly varying load, trapezoidal area in form. So let us try to divide this into two triangles. So this is now your distributed loading. So first, I'm going to consider this as area 1, and that one is now your area 2. Now, such that I will going to consider this one in here as R1. So this is now your R sub 1, and I will going to consider this, the other two, as R sub 2. So this is now your R sub 2. Now, so if this distance in here, so first, let us try to determine the value of R sub 1. So the value of R1 is equal to the area of the load diagram. Okay, so and the area of the load diagram is now equal to 1/2. Multiply this one by W1 multiply this one by 35. Okay, so that is 35. And this is equal to 17.5 W1. And this is acting at 1/3 of 35, or this is equal to 35 all over 3 from, okay, so I'm going to consider that this is now point A. So that is from point A. Hence, this is equal to 35 all over 3. This is now your 35 all over 3. Now, your R2 is equal to the area under the load diagram. And again, still a triangular area. So we have 1/2 W2 multiply this one by 35. And this is equal to 17.5 W2. And this is acting at 2/3 of 35. So it is acting at 2/3 of 35 from A. Or this is equal to 70 all over 3. Now, let's try to take moment about point A. So that summation of moment about A is equal to 0, counterclockwise moment positive. R1 multiply this one by 35 all over 3. So this is the moment arm. Plus R2 multiply this one by the moment arm. And the moment arm is 70 all over 3. So this is your 70 all over 3. Okay, so this is 70 all over 3. Apply this one by 70 all over 3. Okay, so we have, this is going clockwise, so minus 12,000. Multiply this one by the moment arm, 5 plus 9, or that is equal to 14 inches. And this is equal to 0. So R1 is 17.5 W1. Multiply this one by 35 all over 3. Plus R2 is 17.5 W sub 2. We have 70 all over 3. Is now equal to 12,000 by 14. So that is 168,000. So this is 204.167 W1 plus 408.333 W2 is equal to 168,000. So this is now the first equation. Next, summation of forces vertical is equal to 0, upward forces positive. So we have R1 plus R sub 2 minus 12,000 is equal to 0. So your R1 is 17.5 W1 plus R2 17.5 W2 is equal to 12,000. Let us consider this one as the second equation. Now, let's try to solve equation 1 and 2 simultaneously. So we have your equation 1. So we have to multiply this by 17.5. So 17.5 by 204. So we have 3572.9225 W1 plus 17.5 by the 408.333. So this is equal to 7145.8275. This is W2. So this is equal to 168,000 by 17.5. And that is equal to 294,000. So we have equation 2. Let's try to multiply this one by 408.333. So we now have 71.45. 7145. So we have 7145. So this is your equation 2. 7145.8275 W1 plus 408.333 by 17.5. 7145.8275 W2 is equal to 12,000 by this one. So we have 489. 489. Okay, so we have 9996. So that is 4899996. So let us try to subtract the two equations to eliminate W2. So this is now equal to, so we have minus 3572.905 W1, so is equal to 0. So that is therefore equal to minus 195.9996. Hence, W1 is, okay, negative and negative cancels out. 195.9996 all over 3572.905, or this is equal to 548.572 pounds per inch. So that is the value of W1. Let us try to substitute W1 in either equation 1 or equation 2. So from equation 2, So this is your equation 2. So we have 17.5 by W1, 548.572 plus 17.5 W2 is equal to 12,000. Hence, we now have 17.5 W2 is now equal to, this is equal to 2,399. 12,000 minus this, that is 2,399.99. So your W2 is now equal to 2,399.99 all over 17.5 is 137.142 pounds per inch. So that is the value of intensity W1 and intensity W2 acting at the base of the wall footing. Okay, so for this problem, a cylinder, so this is your cylinder, is supported by a bar. So you have bar CB and a cable as shown. So you have your cable AB. The weight of the cylinder is 150 pounds. So weight of the cylinder is 150 pounds. And the weight of the bar, so the weight of the bar is equal to 20 pounds. Now, if all surfaces are smooth, okay, so all of these surfaces in here are smooth, determine the reaction at support C of the bar and the tension in the cable. So let's try to determine the reaction at support C and the tension in the cable AB. So first, let us try to draw the free body diagram of the cylinder. So this is now the free body diagram of the cylinder. So we have your cylinder. So that is the center of the cylinder. Okay, so we have the weight of the cylinder. This is now the weight of the cylinder, which is equal to 150 pounds. Now, we have the reaction between the smooth surface. Okay, this is smooth surface and the cylinder, and this is perpendicular. The reaction is perpendicular to their point or contact point. So this is now, I'm just going to consider that this is now your R1. Also, the contact reaction between the cylinder and that of the bar BC. So we have, this is now your R sub. So I'm going to consider this one as R2. So we now have R sub 2. Okay, so the angle, or the slope of this R2 is now equal to, so this is now equal to, okay, 4 vertical and 3 horizontal. So your R2 is perpendicular to the bar BC, which has slope of 3:4. And if this is the perpendicular, the slope is now equal to 4 and 3. And this is now your 5. Let's try to determine the components. So let's try to determine the components of R2. So we have, this is now R2 horizontal, and this one is now your R2 vertical. Okay, so that your R2 horizontal is now equal to your R sub 2 multiply this one by the horizontal slope 3 over the hypotenuse, 3 all over 5. And your R2 vertical is equal to R sub 2. We have 4 all over 5. It's 4 all over 5. Now, such that if you try to take summation of forces vertical in the FBD of the cylinder is equal to 0, upward forces positive. So your R2 vertical minus 150 is equal to 0. Hence, your R2 vertical is equal to 150 pounds. Next, summation of forces horizontal. Summation of forces horizontal is equal to 0 to the right forces positive. So we R1 minus R2 horizontal is equal to 0. So your R2 horizontal is equal to, so you try to take note that your R2 vertical, from this equation, your R2 vertical is equal to 150 is equal to R2 multiply this by 4 all over 5. Hence, your R2 is now equal to 150 by 5 all over 4. So, the reaction between the cylinder and the bar is equal to 187.5 pounds. Now, hence, your R2 horizontal is, your R2 horizontal is equal to R sub 2, 187.5, multiply this by 3 all over 5. So, if you try to get now summation of forces horizontal is equal to 0, R1 minus 187.5 multiply this by 3 over 5 is equal to 0. Hence, your R1 is now equal to 112.5 pounds. So that is therefore the value of R1. Okay, let us try to consider A, B, and C. So this is now your A, B, and C. So the distance from point A to point C is 36 inches. And the distance, the horizontal distance of a bar BC is 32 inches. So let us try to determine the vertical distance of bar BC. And that is equal to y. So using now your similar triangle, y is to 32. So your y is to 32 is equal to 3 is to 4. Is 3 is to 4. Hence, the value of y is now equal to 32 by 3 all over 4. And that is equal to 24 inches. Let us try to determine the value of y1. So this is your y1. So it is 36 minus y. And that is equal to 36 minus y, or that is 24, or that one is equal to 12 inches. Now, let's try to determine now your length BC. So what is length BC equal to? So your length BC is now equal to the square root of 32 square plus y square, which is 24 square. And this is therefore equal to, so your length BC is equal to 40 inches. We have 40 inches. Now, so if you try to get now the center of the bar, this is the center of the bar. So this one in here is 20. This is now 20. Now, and this one in here, the slope in here is now equal to 5. Now, again, using similar triangle, we now have x1. So this is x1 is to 20. So x1 is to 20 is now equal to, we have 32 is to 40. That is 32 is to 40. So your x1 is now equal to 16 inches. That is the value of. Now, let us try to draw now the free body diagram of bar BC. So we have the weight of the bar, and the weight of the bar is 20 pounds. This is equal to 20 pounds. So we have the reaction at point C. This is your B, and this is now your point C. Now, so we have RC vertical, so that is hinge. So we have horizontal and vertical reaction. This is now your RC horizontal, and this is now your RC vertical. Now, we have the reaction at point 2. So this is the reaction at point 2 perpendicular to bar BC. And this is your R sub 2. And also, the tension in the cable AB. So we now have the tension in the cable AB. So I'm going to consider that this is now your T. Now, such that the slope is equal to. So I'm going to get now the slope of the cable. So that is equal to. Now, this is y1 is 12 and the horizontal distance is 32. So if you try to divide that one by, so let's try to divide that to get the slope. So let's try to divide that one by 4. So your 4, so we have 12 over 4, so that one is equal to 3. And 32 over 4, that one is equal to 8. And therefore, this is equal to the square root of 64 plus 9, or the square root of 73. So it is equal to the square root of 73. Now, let us try to have now the distances. So this distance in here, so this one, up to this one, and this one. Okay, so you try to take note that this one in here is your x of 1. So this is your x of 1. And your x of 1 is equal to 16 inches. Okay, this is now your 32 inches. We have 32 inches. Now, so that this distance in here, up to this point, is now your y. And this is therefore equal to. So this one is now equal to. Y is 24 inches. So that is equal to y. And this is perpendicular. So this one is 17 inches. Now, let us try to determine the horizontal and vertical component of the cable, the tension in the cable AB. So we have the this is now your T horizontal, and this one is now your T vertical. Now, so that your T horizontal is now equal to the tension in the cable, 8 over the square root of 73. And your T vertical is now the tension in the cable, nebaliktad, that is your T vertical. And this one is your T horizontal. That is 8 over the square root of 73. So your T vertical is equal to the magnitude of the tension, multiply this one by 3 over the square root of 73. So let us try to take moment about point C. Summation of moment about point C is equal to 0. Then, counterclockwise moment, positive. So, your T horizontal going counterclockwise. The moment arm is 24 inches. Okay, plus your T vertical also going counterclockwise. Now, the moment arm is 32. And then, your 20 is going clockwise, minus 20. Multiply this one by the moment arm, which is equal to 16. Minus r of 2. And the value of r sub 2, we have taken this 187.5. 187.5. So that is the value of r sub 2. So this is going clockwise. So minus 187.5. The moment arm is 17. So this one in here is 90 degrees. And this is therefore equal to 0. So TH is equal to T 8 over the square root of 73 by 24 plus TV is T multiply this one by 3 all over the square root of 73 multiply this one by 32. And this is equal to 20 by 16 plus 187.5 by 17 is equal to 3507.5. So we now have 33. Okay, 24 by 8 over the square root of 73. 32 by 3 over the square root of 73 is 33.708 T. And this is equal to 3507.5. So the tension in the cable BC is equal to 104.055 pounds. So that is the tension in the cable BC. Now, let us try to determine now the value of TH. TH is equal to T, and T is 104.055. Multiply this one by 8 over the square root of 73. And this is equal to 97.43. And then your T vertical is equal to T 104.055. Multiply this by 3 all over the square root of 73. So that is equal to 36.536 pounds. Okay, so let us try to take now from this figure summation of forces. Horizontal is equal to 0. To the right, forces positive. So we now have your RC horizontal. So your RC horizontal plus we have your R2 horizontal again. So we have the components of R2. So the components of R2, so we have R2 horizontal. So this is R2 horizontal, and this is now your R2 vertical. So we have R2 vertical. So summation of forces horizontal, RC horizontal plus R2 horizontal minus T horizontal is equal to 0. So we now have your RC horizontal plus, you try to take note that R2 horizontal was computed before, and that is equal to 112.5 pounds. Minus TH, which is 97.43 minus 97.43, and this is equal to 0. So your RC horizontal is equal to negative 15.07 pounds. Okay, what does the negative sign in here? What does the negative sign mean? Hence, your RC horizontal is equal to 15.07 pounds. We assume RC horizontal to be going to the right. Okay, since we get a negative value, then the correct direction of RC horizontal should go to the left. Summation of forces vertical is equal to 0. We have upward forces positive. So we have RC vertical. And then we have R2 vertical minus R2 vertical. Then we have plus T vertical minus 20 is equal to 0. So your RC vertical minus R2 vertical is equal to 150. That is 150 pounds. Plus T vertical 36.536 minus 20 is equal to 0. So your RC vertical is equal to 133.464 pounds. Let us try to determine now the total reaction at point C, and let us consider that one as RC. So this is equal to RC horizontal square, 15.07 square, plus RC vertical square. So your RC is now equal to 134.312 pounds. So let us try to determine now. So your RC in here is, so we get a positive value, therefore the assumed direction is correct. So that is up to the left. It is up to the left. So let's try to determine the angle of the total reaction at point C from the horizontal. And this is equal to the arc tangent of RC vertical, 133.464, all over RC horizontal, 15.07. And this is equal to 83.56 degrees.